Welcome to the Module 9 project. There will be 13 exercises, actually more than 13, but 13 that will be pretty straightforward. And then there'll be a few more where we'll actually code in VS Code and complete them over there. So this video will cover these first 13. All right, exercise 1, use a for loop to sum up all the numbers from 1 to 1,000. So the way we're going to do this is just begin with a variable called sum and set it equal to 0. And then we're going to loop through with a range object. So I need to go from 1 to 1,001 because it goes up to but does not include the last one. And then all I'm going to do is use the plus equals, and I'm going to add I to it. So it's going to continually add and reassign the value of total. And then I'll have total like this. Okay, so that is the answer for that. Exercise 2, use a for loop to calculate the mean, which is the average from the given list of values. So the mean is just the total of this divided by the total number. So let's use a for loop. We're going to go through these one at a time. We'll say for val in values. And again, we need a total over here. And we'll make it 0. So we'll do the same kind of thing, total plus equals val. So we're going to accumulate the values, and then the average will not just be the total, be total divided by the number of values, and we can just use the len function. So this will be 4. We could have just put 4, but so we can calculate it programmatically, we'll do this. So that is the average. Exercise 3. Calculate the sum of the squared values of each of the first 100 positive integers. Okay, so that is a little bit more challenging, but it's the sum of the squared value. So really, let's just go over here. We'll copy and paste the code from number 1, and not of the first 1,000, the first 100. So we're going to go from 1 to 101, which really means 1 to 100, and we are going to square each of those values and then add it to the total. So what happens here first is that I gets squared and then adds it to the total and reassigns it. So that'll be that value right there. Number 4, use a for loop to iterate over the first 10 positive integers, printing out their squared value only if their value is greater than 50. So we're going to iterate through the first 10 positive integers. So again, we're going to do 1 to 11 and printing out their squared value only if, I should say, their squared value is greater than 50. Okay, so we'll say if I squared, and maybe we'll create a variable here, squared equals I squared. So if squared is greater than 50, then we will print out the squared value. Maybe we can print out both. We can say I squared is squared, like this. So the first one is 8. 8 squared is 64. Before that is 7, which is 49. So it doesn't get, this if statement doesn't get triggered until I is 8. Okay. Number 5, use a for loop to iterate over every 25th positive integer up to 200, appending a square value to a list. Okay, so we're going to go over every 25th integer. So for I in range of, we'll say 0, 200, 25, and positive integer, so we'll say 1 to 201, going by 25, and then, so this is start, stop, and step. So we need to find the squared value. That's great. So let's print this out. Okay, that's fine. We could say 0 to 201. That way the first one will be this will be 25 squared. It doesn't really matter. That's not really the point of the exercise. The point of the exercise is just to be able to go and loop, but depending on how you want to interpret this. Anyways, let's create a list called squared. And the idea here is to append the squared value to the list, and then we can print out the list like this. Okay, so every 25th, that is the step size. Number 6, calculate the variance of the following list of values. So the variance is a statistical calculation, and it gives you the formula over here. To calculate the variance, first calculate the mean and assign it to a variable. Then iterate through each value and find the difference between it and the mean. Square this difference. Finally, sum the squares of all these differences and divide by the total number of values. Okay, so that is a mouthful, and we'll just do it one at a time like it says. First, calculate the mean and assign it to a variable. So we calculated the mean before. We could just go back over here and do this. So for val and values, the same thing. We use a different, same variable name. So the mean, let's go ahead and call this mean now, and we'll run this. So that is the mean of these, looks like 6 values over here. And 1, 2, 3, 4, 5, 6. Yep. All right, now it says then iterate through each value. So we have to do this again for, let's leave a space, for val in values again. So it's kind of weird. We iterate through them again and then find the difference between it and the mean. So we'll say mean, say diff equals mean minus val. Square this difference. So we'll just do this all in one line. Maybe I'll change this to squared difference. Or maybe I should say difference squared. Finally, sum the squares of all these differences and divide by the total number of values. All right, so we have a total different squares. So for each one of these squared, we will then do plus equals different squared. So, so first we find the mean, then we iterate through each one of the values. We find the difference between the mean and the current value, and we square it. So we're collecting all these squared differences, and then we're going to just accumulate them into some other variable. So there is the total difference squared, and then divide by the total number of values. So we just take this total difference is squared, and we divide it by the length of the values, and that is what we get for the variance. All right, number 7, use a for loop to iterate over every integer from 100 to 999. Add the first and last digits to, assign the first and last digits to variables, and then create a list of only the numbers where the first digit is exactly 7 more than the last digit. So there's a couple ways of getting the getting these first and last digits. So let's just say we have a number. Before we actually do this, let's say we have a number 129. So how do we say, all right, how do we get the 1 or the 9? This is a little tricky. There's a couple ways of doing this. You can convert it to a string. The hint says use integer division and the modulus operator. Okay, so to get the first digit, one way is to do integer division divided by 100, like this. So how many 100s go into 129? Well, that is 1. And as you can see, it'll work to get that first one. So I change it to 229, 529. There's 5 100s that go in there. So that's a little tricky. To get the last digit, we will use the modulus operator, not with 100, but with 10. That's how you can get the last digit. So that's just a trick to get the very last one. So if it's, let's say 125, it'll be 5. If it's 120, well, then 10 goes in there evenly. There will be no remainder. So this is a little tricky one. You have to, be aware of how to use integer division and the modulus operator. So let's go ahead and use this trick now. So for I in range of 100 to 1,000, so this will go all the way up to 999, we will get the, we'll say the first digit is just I integer division 100, and the last digit is I modulus 100, sorry, 10. And then it says create a list of only the numbers where the first digit is exactly 7 more than the last digit. So if the first is 7 more than the last, so if we say first minus 7 equals last, so if the first digit is, say, 9 minus 7, and the last digit is 2, then that will work. If the first digit is 8 minus 7 is 1. If the first digit is 7 and the last digit is 0, that will also work. And this needs to be equals, not assignment statement. So we're saying if first minus 7 equals last, then we will create a list. So we need a list of these numbers. We'll just call them nums and make a empty list over here. Say nums.append the digit, so I. Then it says output the first and last 5 numbers of this list to verify that it is correct. Okay, well, let's just look at all of the list. We can verify that it's correct. So is the first digit 7 more than the last? Okay, that looks good. 7 and 0, 7 and 0, 8 and 1, 8 and 1, 9 and 2, 9 and 2. That's very good. So those are all the combinations. Got to either start in 7, end in 0, start with 8, end in 1, or start with 9 and end in 2. Okay, so to print out the first 5, we use slice notation, and the last 5, we also use slice notation. All right, exercise 8, use a while loop to find the sum of all integers between 0 and a given integer x. Output result. So a while loop, this is not a typical use case for a while loop, but you can certainly do that. So while x is greater than 0, and what we need is a total. So we will increase the total by x, and then we will decrease x by 1. So we're going to keep making go lower and lower. So it will begin at 20, we will add it to there, then it will become 19, and so forth. Eventually it'll become 1, and then 0. 0 is greater than 0, that is false. And we didn't print out the total. So that'll be the total, 210. All right, exercise 9. Assign x to a positive integer. Use a while loop to find the sum of all integers between half of x and x. Okay, so let's go ahead and actually just copy this code over here. Use a while loop to find the sum of all integers between half of x and x. So again, a while loop this is not the best or the most direct choice. So we'll say half of x equals x, and we'll just say integer division 2. That'll give you half of x. So while x is greater than half of x, then we will do the same thing. So it's going to keep on, x is going to keep on counting down, and here half of x will be 10. So once it's 10, then it will exit the loop. So we can actually print to test this. Sometimes you can just use the print statement in here and print it out. So that looks good. You could say greater than or equal to if you want to get to exactly 10, but this is good enough for the solution. All right, exercise 10, use nested for loops in this exercise. So write an outer for loop to iterate over the numbers, over the integers 0 through 9. Within this for loop, write an inner for loop to iterate over the numbers integers 0 through 4. Create 2 separate variables to count the total number of iterations for each loop and output their values. Is it what you expect? Okay, so the variables have already been created. This is just a double check that everything is happening right. So we'll say for I in range 10, this is the outer loop, 0 through 9. And we're going to increment the outer variable, the outer loop. We're counting how many times this happens, right? And now we're going to iterate through the integer 0 through 4, which is range 5, right? Because it goes 0 through 4. And then we're going to say count inner plus equals 1. And then we will just print these out. We can use an F string. We'll say outer is count outer, and inner is count inner, like this. Okay, so the inner loop is being run 5 times every time the outer loop runs once. So it'll happen 50 times. The outer loop is run 10 times. Okay, number 11. A well-known property of right triangle is that the hypotenuse squared equals the sum of the squares of the other two sides. This is known as the Pythagorean theorem and is usually written as a squared plus b squared equals c squared. So a Pythagorean triple is a set of 3 integers that satisfy the theorem. So for instance, 3, 4, and 5, or Pythagorean triple, as 9, 16 equals 12, right? So 3 squared plus 4 squared equals 5 squared. So if you have a right triangle where these are the sides, 3, 4, and 5 are possible as integers. Most integer combinations are not possible. They have to be exactly a squared plus b squared equals c squared. Can you find all of the Pythagorean triples where all sides are less than 20? Okay, so sounds like a tough task. We have to find all of these combinations. And so what I'm going to do is I'm going to have a variable a. This is less than 20. So for a in range, we don't have to check 0. You can have a side that is 0 in length. It says less than 20, so we'll go from 1 to 20. And then we're going to do b from range, same one. And then we will do for c, this is a triple nested loop, like this. So for all of the a sides that go from 1 to 19, it's going to test all of the sides that are b from 1 to 19, and also test all the sides c 1 to 19. So it'll do all of the combinations. It's actually a lot of combinations. 19 times 19 times 19. That's how many total combinations there are. So what we want to do is find all the combinations such that if a squared plus b squared equals c squared. And if that is true, we're going to print out the combination. We'll just say, I will just print them out, a comma b comma c, like this. And these are all the combinations. Like that. So 3, 4, 5, the other two sides don't matter. 4, 3, 5, 5, 12, 13. You'll also see it over here, 12, 5, 13, and so forth. So it checks all those 19. So there's almost 7,000 different combinations that are possible. And of those 7,000, these are the only ones where that will be Pythagorean triples. Okay, number 12. When rolling 2 dice, there are 6 combinations that make a total of 7, and 2 combinations that make a total of 11. Theoretically, 7 should be rolled 3 times as often as 11. So 6 combinations versus 2. Simulate the rolling of 1,000 dice to verify that this ratio is likely correct. Okay, so we're going to roll 2 dice 1,000 times. So we're going to do for I in range 1,000. And let's just get the total of the dice roll. So we're going to get we're using the random module. So we talked about this before. This will be dice roll 1. We won't save it to a variable first this time. We'll just do it all in one line. So we're going to get the roll like this. And maybe I can just say roll instead of total. So we're just going to add 2 dice rolls together, 2 die rolls together. And if the roll equals 7, then we have to keep track of this. So we'll say count of 7s is 0. Count of 11s is also 0. So if the roll is 7, we're going to increment the count by 1. Otherwise, if the roll is 11, we will increment count 11 by 1. And then we don't have to have an else, just nothing else will happen. We're not going to do anything else. And then at the very end, we will print, we'll say 7 rolls, and we'll put count 7, and then 11 rolls, we'll put count 11. And these should be about 3 times, there should be about 3 times as many 7s as 11 that are rolled. Okay. So let's go ahead and run this. So I run it 1,000 times. There's 162 7s, 49 11s, and yes, it's not exact. It's not going to be exactly 3 times, but 3 times about 50 is 150. So it's fairly close. You could actually have another one and say the ratio is, and you can just say count 7 divided by count 11 like this. So I just did it again. So 169 to 67 is a 2.5 to 1 ratio. Do it again. Oh, this is almost exactly 3 to 1, right? 50 and 151. I'll just stop there. I'm not going to get any luckier than that, but that's what it should be approximately. All right, so let's do number 13, last one for this. Create a simulation to estimate the average number of rolls of 2 dice it takes until you get a total of 7 or 11. This will require nested loops. Okay, so what this is asking is that you're going to keep rolling a dice until you get a 7 or 11, and you're going to mark down how many times, how often that happens. Right, so does it happen on your first roll, on your 5th roll, on your 20th roll? When does this happen? And then you're going to find the average number of that. Okay, so it doesn't say how many times to run this, but we're going to keep on rolling until we get it. So let's just do part of the problem. So let's just say we have a roll, and it'll just be this. We're going to roll. And and actually this is the time we'll do the while true. So we want to roll at least 1 time here. So I'm going to do this pattern. While true, if roll is in 7 or 11, so that's how we can test if it's one or the other. We can also say equals 7 or equals 11. And we'll have a count variable. So count equals 0. Actually, we'll break over here. And we'll put the count up here. So what's going to happen is that, so count is set to 0. We're going to increment the count. So this is how many rolls there are, right? So on our first roll, we will get this. And if the roll is in 7 or 11, then we will break out. And that's how many rolls it will take to have reached a 7 or 11. Let's go ahead and run this. So in this simulation, it took 2. Here it took 8. Then 1 roll, 2, 1, 2, 8, and so forth. So what this asks is how can we find the average number of rolls? So how do we average all of this? Well, it says we need to have nested loops. So what's going to happen here is that now we need a for loop, and we need to do this some number of times, a large number of times to get a simulation. We'll just say 1,000 times. So it's like an experiment. We're going to repeat this experiment 1,000 times. So each time we reset the count, so we'll go back to 0, and then we will run the experiment. And once it hits a 7 or 11, we will break out. And what we'll do here is we'll just keep track of how many times it takes to reach this. So we'll say the total, we need to find the average. So we're going to just accumulate this count. So let's just say it took 2 times on the first one. So the total becomes 2. On the second experiment, it takes 8 rolls to get a 7 or 11. So then you get 2 plus 8 is 10. The average for that would be 5, right? Because we had 2 experiments and the total was 10. So we divide it by 2 and get 5. So the average will be, at the end over here, we have total divided by 1,000, right? So we have 1,000 experiments. And then we're going to just keep track of the count, or accumulate the count, and then divide it by 1,000. Okay, so let's run this. So this was 4.4 times. That was the average number of rolls it took. And if we run this over and over again, it should be right about the same number. It shouldn't deviate too much. If we do it, we can do it 1,000,000 times. This actually takes a little bit of computer time, as you can see. It took, this should be 1,000 or 1,000,000, so this is really 4.5. Anyway, so if you increase this number, it will take longer but give you a little bit more accurate results. Okay, so that's how you do number 13.